All right, let's talk about percentages. Now, with percentages, the majority of the real-life math problems you're going to run into deal with percentages. Looking at the enrollment, most of you guys are in turf management, so you have to deal with a lot of percentages in everyday aspects for math problems that you're solving, even if you're not in the turf management program. I mean, every trade uses percentages in some form or fashion. As you can see, I got 3 different percent problems set up here. These are kind of the basics of finding percentages. Hopefully you watched the video earlier about changing percents into decimals and vice versa. I think that's pretty simple enough to figure out. Now there's two main methods we can solve for these problems. The one I'm going to show you in this video is proportions, and then I'm going to post the algebraic way of doing these as well. Okay, so the proportions way, it kind of depends how you feel about percentages. Proportions do make things easier. They are kind of consistent with what we've been doing so far, but at the same time, some people can find the proportions a little bit too tedious. So let me give you the basic setups for proportions here. We're going to be using this one up here as our main example. So let me get up the rules here. Let's see. So the proportions setup, it's a pretty simple setup. There's 2 ways you can look at it. It's the part. Oh wow, that did not show up very well. So let me see if I can write this again. It's the is over the of equals what percent you're trying to find or have over 100, or it's the part over your base or whole, whatever you want, whatever term you want to use, still equals your percentage over 100. Okay, so with this one, the is and of for some of the practice problems you'll do, this is a really helpful verbiage, but just know that this and this are the same thing. Okay, and the good thing, since these are proportional and proportional relationship, you can solve it by cross multiplying and dividing. So if you like consistency, the proportions a little bit better. And proportions too, they help you organize things a little bit better, I think. But when you look at these ones, these are the same things, just 2 different ways of saying it. Okay, so let's go back to the original problems there. Pull these back up. Okay, so our original question up here, they asked, what is 35% of 20? So when you're dealing with a lot of percent problems, this is the main percent thing you're going to do, is you're going to find the percentage of a number, and either just find the percent of a number. What we'll do later is we'll find percents of numbers and either add or subtract, and there's ways of getting around that too. But let's just focus on the basics here in this video. So we look at this one. If I was going to set this up, now the keyword right here is they said, here's your is and here's your of. Now when you set this up as a proportion, you always put 100 over on the right hand side. I mean, it doesn't have to be on the right, it can be on the left, but I think with these things, the more consistency you have, the better off you are. So we look at this one, the hundred's there for the percent part of the proportion. So remember, only percents go over 100. Do not put anything other than a percentage over the 100. So with this part, when I'm trying to solve this, I should automatically know where the 35 goes. 35 will go over the 100. Okay, the 20, they said of 20. So that's telling us it's our base. So we put the 20 down here. And then we're looking for, they said what is, so we're looking for a part of 20. Now with this one, right now I'd kind of encourage you to pause the video and just get a quick mental estimate of what this should be. When I do this in my head, I always kind of use halves as a reference point. So with 20, I think, what's 50% of 20? Well, that's about 10. 35% is less than 50, so we should be under 10 for our answer here. But in case, we'll use the math to confirm it. So we do x. So we do 100 times x, that is 100x. Then we do 35 times 20, that gives me 700. Then we just divide both sides by 100. I don't know why I just picked up a triangle there. Let's see, divide by 100, so all the zeros cross out. We get x in this case equals 7. If we look at that, that seems like a pretty reasonable answer for what we're doing. Okay, that's the one thing I like about percentages is you should be pretty easily get an estimate of where your answer should be, because I mean that's why they kind of use percentages. Percentages are adaptable. You know, when something's out of 100, it's really easy to visualize in your head. Okay, but we look at this one. You know, the setup's pretty basic. Let's go next one down here. So they said 15 is what percent of 50? So when you go to set this one up, you automatically know. Oops. You go to set this one up. Always put the 100 there. Now with percents, the 100's always there. You should know, okay, they said what percent, so I automatically know. Oops, I'm having trouble with my pen here. That the x goes over 100. Okay, now we look at this one, they said of 50, so that's the total we're trying to find, because they're saying what percent of a bigger total. So 50 goes in the bottom corner here, and then 15 is the part we have, so we put 15 on top. Okay, so it's kind of like you're figuring out test scores. You know, if you got a 15 out of 50, obviously you didn't score very high. So, you know, you shouldn't have to be a math expert to figure that out. But let's see. So let's cross multiply and divide here. So we take 15 times 100. That gives me 1500. I can do that one without the calculator. Let's see, we do 50 times x. Gives me 50x. And we'll go ahead and divide by 50 to finish out the math. Cross that out. Divide this by 50. So those cancel out. And let's see, 150 divided by 5. So give me x equals 30, and in this case, 30%. Okay, which that seems reasonable, you know, because when you look at this one, you know, 30% seems pretty feasible for 15 of 50. Okay, so again, I kind of use the halfway mark as my barrier here, or as my benchmark. Is like, okay, what's half of 50? That's 25. Well, we have under 25, so we have under 50%. You know, and there's all different ways you can figure it. I just use 50. A lot of people use 10% because 10% is really easy to figure of a number. You know, it's like even if you have a number, even if we have a number like 50, if I want to find 10% of that, put it up here. If I want to find 10% of 50, all I do is just move the decimal over one spot. So 10% of 50 is 5. And then I figure, okay, if 10% is 5 and I have 15, how do I get from 5 to 15? Well, I times by 3. If I do the same thing with the percentage, I get my 30%. So that's another way you can look at it. You know, kind of a little bit more complex, but still not that bad. Okay, now this one, this last one, this is probably the most challenging of all the three you'll see. So here the first one we did, finding the percentage of a number, the most common. Next one is actually finding the percent when you have your part and your total. The third one is finding the base. Okay, now you will have to use this from time to time when you know what your total is supposed to be, but you don't you know what your total is supposed to be, but you don't know what it's out of. You know, like if you ever have to take a soils class, you know, it's like a 17 pounds of nitrogen, and each bag of fertilizer is only 2%. How many pounds of fertilizer do you have to buy? Something like that. So you know, when you're finding percentages or bases, you know, this is a useful skill, but this one's a little trickier. Okay, let's see. So we put this 100. So the 2%, again, it's a percent, so we automatically know where it goes, over the 100. Okay, so now we look at the 17. Here's where most people screw up in this one. They said 17 is 2% of what number. So the of what number tells me the base is unknown. So my x goes in the bottom in this case. I don't know why this thing's trying to recognize shapes, and I don't know why it's doing that. Let me see if I can. Okay, let's see if we can get that fixed. I'm having all kind of technology problems. Let's see. Nope. Come on. Okay. Let's try that again. So they said of what number? So that implies the x is unknown. Okay, so now the 17 will go on top. Okay, because that's the part. And one thing you got to realize with these proportions, that's kind of why I like them, is the number you put here correlates to the percent it's across from. So they said 17 is 2%, so 17 is across from the 2 because that's what number it correlates. And instead of being out of whatever base we're going to find, 2 is out of 100. You know, naturally 100 correlates with the base. So then we just cross multiply. We take 17 times 100. That gives me 1700. 2 times x gives me 2x. Divide both sides by 2. Divide this by 2. So cross that out. Let's see, 17 divided by 2, I think that gives me 850 equals x. Okay, so when you look at this one, you know, pretty simple method. And a way I could check this if I wanted to, I guess using proportions, is I could reverse it and see if I get the same thing. So, you know, if I, let's see, so if I put 850 down here, and then I put 2 up here over 100. So basically I'm reversing it, so saying if I know this is the base, if I find 2% of that, it should be 17. Okay, so we cross multiply, so we get 100x equals, I'm running out of space here, 1700. Divide both sides by 100. That crosses out that, zeros cross out, so I'm just left with 17, so it fits. Okay, so when I found 2% of 850, it did work. We got the same thing we started with. So that's the kind of the thing I like about percentages, is they can be checked a multitude of different ways. Now I only checked this one because of all the 3 situations we ran into. You know, we got first one here, second one, the third one. I think this is the one where people mess up the most. So, you know, if you're not sure, just take the number you found and see if you get the number you started with. Okay, so we found 850, and then I found 2% of that because we're saying 2% of something. Well, the something we found was 850, and they're saying it should be 17 because 17 or is means equals 17. We did that and we got the same number, so everything fits.